Okay, it'd be great just to start with a little bit of background on Turley as an organisation, a little bit of the history, key milestones, yeah, and anything you can tell us.
So Turley's an advisor in the built environment. We're predominantly a planning consultancy, so we advise a lot of people building data centres and finding sites for data centres, that kind of thing. We're based in the UK and Ireland. I think we've got 15 offices now, and there's about 300 of us working. Within that, I work in the sustainability and energy team, and so we do a lot of advice on new development on the sustainability and energy side. But we also advise large corporate organisations on their decarbonisation journey, their net zero strategy, that kind of thing.
Okay, and in terms of data centers and AI, which everyone is talking about, perhaps before we look at the impact of AI, it'd be good to understand your thoughts as to where the industry is now. Clearly, sustainability has been on their agenda for a while. There was
Yeah.
maybe the first iteration when everyone was busy sort of planting trees, shall we say, to offset their carbon
Yeah.
footprint, and that was about as sophisticated as got. I think the industry's moved on from that, but just your thoughts as to where the industry is, and then we can talk about maybe the impact that AI will be having or is having.
Yeah, well, so the industry, the data center industry has always been energy focused because it's such a large part of its cost base. And so that has the fortunate benefit of making people focused on energy efficiency. And not an expert on IT systems, but there has been greater efficiencies. I understand it. Data center power demand has been growing a lot slower than our data demand has been growing, if you like. So we have been much more efficient in our use of energy. The Well, maybe we'll come on to the AI, but I think what now is happening is there's a bit more sophistication happening in terms of it's not just using less energy. We're looking at things like generating our own energy, how data centers interact with the grid, which is like something I'd like to talk about a lot because I think that's a really big, important part. And we're seeing clients looking at things like cogeneration, so having solar next to the data center, for example. So there's a bit more sophistication going around that. The other thing I think is almost all big organizations now have a net zero strategy. And so, again, it's more focused on how we get to net zero rather than just how we be efficient.
Okay, yeah, and then I won't call it the elephant in the room because everyone is talking about it, but
Yeah.
AI is here now and is, depending on predictions, is going to change the world sort of massively, or whatever, Armageddon. I don't know how to
Yeah,
describe
yeah.
it. Anyway, and data centers are, I won't say they're struggling, but obviously they've got their net zero targets now. When, if you like, the demand is already creeping up just because of the evolution of the digital world, and then AI comes along. So the power requirements, the demand's going to go up massively. So from your, if you like, conversation, do you think the industry, hopefully it's aware of it, but do you think fully prepared for what's heading its way?
Yeah, I don't know. I don't know if any of us are. I mean, there is a lot of work and projections and analysis going on. So to give you a quick example, the National Grid um, tell us that the data centers use about 1% of our electricity demand at the moment, but they're predicting that's going to grow over the next decade sixfold. So that takes you to somewhere around 15 terawatt hours, which will probably be something like 4 or 5% of the energy demand in the UK. So there is that projection going on, and that really is huge. Just the whole office sector in the UK uses about 5% of our electricity. So like you say, it becomes a really big issue. I don't know if the sector's ready for it or not. I don't know, but we clearly are talking about it because there's data out there. So
But I guess it's fair to say that to meet that kind of um, anticipated growth in demand, the industry probably can't carry on as is, expecting just the grid to provide it with electricity, or however it's getting it. So a
yeah,
new approach is needed, and I'm just some of the things that you mentioned, microgrids, and I've had one or two conversations with people. So
yeah.
what's going on with that? What's the potential, I guess, for microgrids, and what's stopping the industry as well, I suppose, deploying them more than they currently are?
Okay, so that's a good question. Just before I answer that question, just I think it's a really important thing to understand in energy terms is there's two things to think about. There's the total energy you use, which you measure in kilowatt hours or megawatt hours or gigawatt hours or terawatt hours. And there's how much power you use, which is the instantaneous load that you're putting on a system. So when you put your kettle on, you're using loads and loads of power, but obviously you only put your kettle on a few times a day. So the total energy your kettle uses is not that much. And that is that's probably the biggest thing we're going to have to get our head around in the data center sector, but the energy sector as a whole. And so to try and explain where we're going, generating more energy isn't actually difficult. We can always build more solar farms, we can always build more wind farms, we can even build nuclear power stations or gas-fired power stations if we want. And there's no shortage of fuel. In renewable energy, it's infinite effectively, and there's no shortage of oil and gas. But as we move to a renewable energy system that's based effectively on wind, solar, and probably some nuclear power, they're very different to traditional power generation in that they are inflexible, in that they can't turn on or can't turn off. In most senses, they can't turn off, or at least they're very inflexible. And so what used to happen in the past was when your data center, and it still happens to some degree, when data center, for example, or any power demand goes up, power stations respond. So our power generation goes up. Our supply system of power is getting less flexible. It's less able to do that, and it will become more expensive to do so in the future, and introduces more carbon intensive generation, because when we peak power, that's when all the gas-fired power stations come on, or the coal-fired power. So the crucial difference in the future is not how much energy you use, it's when you use it. Or at least those two things are as important as each other. And that brings us to this point about microgrids. So as I said before, up to now, the data center sector has looked at efficiency. That PUE measure is pure. It's how much energy you put into how much useful energy gets used in an IT system on an annual basis. It doesn't look at when you're using it and how you're using it. And the idea of a microgrid is simply that a data center would be on the same site as, could be housing, it could be logistics, factories, hotels in a single energy system. And the idea of that is that, for example, logistics sheds often have huge solar roofs. They're great for putting solar on big flat roofs, unobstructed, but they also often don't use much energy. So you often have a shed that's essentially storing things during the day and not using much energy, maybe a small office. But next door, you've got a data center that in a traditional model is just drawing power from the grid, whilst the next door logistics shed is putting loads of power onto the grid, which is crazy for all sorts of reasons. It's crazy environmentally, it's crazy because we have a bigger grid because of that. And of course, it's just economically crazy because there's a big opportunity. So by locating these, and it could be other things, on a single energy system, you can optimize their use by sharing energy around. And that's growing more and more, because with the EV charging revolution we're seeing, and increasingly the HGV charging revolution we're seeing, you've now got lots of big batteries that are connecting to these buildings that can take energy, but they can also supply energy. And so, as I said, in the past, data centers would be pretty passive. They just they used power and they tried to use it efficiently, but they didn't respond. But now there's the opportunity for them to ramp up demand when there's lots of energy and ramp down demand when there's less energy. And I saw a report, I think it was by an organization called Thunderset Energy. I don't know if you've come across them. I think they're an American energy sort of research body that estimated that 40% of data center energy demand is flexible, by which they mean it can be moved around in time. So it's stuff that needs to happen, but it's stuff that doesn't need to happen at 5 o'clock in the evening when the grid's really struggling. It might be able to happen at 2 o'clock in the morning when the grid's less constrained. And the same on a microgrid. So one of the interesting things in the UK is when we generate most solar power is when we use least energy. Because you think about it, it's 2 o'clock in the afternoon, it's July, the heat, nobody's got heating on, the least of us have got lighting on. And so actually we use less energy just when solar is maxing out. The nice thing about a data center is it does track solar power generation quite nicely, because the cooling demand rises as the solar generation rises. And so we just need, the microgrid is a specific example of that, but we need to think about that same psychology on a system level, on the whole national grid.
And how, in terms of, because obviously we've got a massive legacy data center infrastructure already, so how easy is it for them to sort of partner up, if you like, with these microgrids, as opposed to, clearly, if you're building a greenfield, then you cannot put a data center in the middle of, as you say, whether it's an industrial estate or even a housing estate, whatever it is, and build this, as you say, self-contained energy grid. I suppose what I'm saying is, what's the opportunity for this for the industry?
Yeah, so what can be done, and it is being done. So I've worked on projects on industrial sites where they have gone from a traditional sort of linear structure where every unit is connected to the network to a private network where it's operating as a microgrid. I think it does require physical infrastructure changes, but also what it really requires, and this is probably the biggest thing, is a psychology shift. In that, one of the problems, and this is still going on today with new developments, is everyone wants to wrap their arms around enough power demand to guarantee them, we're completely safe because we've got whatever it is, 10 MVA that we need. Even though they vary, in many cases, they're using just a tiny fraction of that. It's that sort of sense of security. What happens when the EV charging ramps up? And so we need to be safe. And the problem with that, of course, is if we all do that, the grid costs go huge and so on and so forth. So I think there's a psychology perspective of getting a group of companies that may be very different companies on the same site and saying, we've done the maths. You don't all need 10 MVA. If there's 10 of you, we don't need 100 MVA. We can manage on 50 because we're not using it at the same time. We've done the maths and you'll be completely safe, but you just need to agree to that. And I think that's a big psychology problem. We see that in all the sectors I work in, logistics, but I would guess data centers are even more super sensitive to that because, uptime is everything and they would be terrified of a power shortage.
And you mentioned the demand flexibility side of things. So again, is that a psychological thing that data center, I mean, I'm sure they understand that, but do they just, it needs to be explained to them sort of in black and white that you can be much more flexible as to when you need the power, etc. So you don't need to your point, put so much pressure on the grid. Just what's the potential there, I suppose, just for the data centers to sort of understand and act on that.
Yeah, so I think there's plenty of it, and I think it's already happening. I'm sure some data energy demand is timetabled to avoid peaks. There's a price incentive because a lot of commercial pricing arrangements will be flexible, so they will be paying different prices at different times. I think we could make that more universal, make that the default. So there's that financial incentive to do it. I think the back to that challenge with the microgrid, it does get complicated saying to a data center, you like 10 times a year, you need your whole 10 MVA, but we'll make sure that's available. But across this whole center, we won't give everyone what they need. I think that's still, I mean, you say, I don't think we need to explain it to them. That sounds a bit patronizing, but I think we need to convince them, demonstrate to them that is, you can be absolutely confident. It's the way a lot of systems work. That diversity, as we call it, diversity of demand, is a well-established principle in electrical networks. But I imagine it would scare a data center operator, naturally.
And in terms of, I think another suggestion is co-location strategies can potentially help with this power demand challenge. I guess just can you expand on that and how the colo industry can contribute in a positive way to what's going on?
So yeah, it's interesting. You say co-location. I think the co-location is mixing two different industrial sectors. You mean co-locating different data center?
I guess, yes.
Company servers. I mean, so I'm not an expert on data center power management, but I suppose there's just economies of scale and the opportunity to use more efficient systems is the big opportunity it presents. I don't know to what degree there's an opportunity again to be more flexible in your power demand because you can aggregate things, or to what degree the servers have to maintain their sort of discreteness. And yeah, I'm not an expert on that, so I don't.
And in terms of renewables, we've talked about those already, and clearly there's already a sort of burgeoning renewable sector, but just your thoughts as to how much further that can contribute to the power infrastructure, energy supply, and where I mean small scale nuclear and green. I have conversations with people about green hydrogen, and in the States it seems to be quite practical because it's available on a scale and can be supplied to people. And then I was at an event the other day where someone was saying, "Oh, why would you have hydrogen? Because it'll blow up your data center." So just your thoughts, I suppose, as to what's possible and are there any, genuine reservations, or that sort of thing, is that just a sort of reason to prevent somebody losing out, for hydrogen, because clearly gas gets supplied everywhere and mercifully doesn't blow up
Yeah.
too many times. But yeah, just your thoughts as to that debate, if you like.
Yeah, I mean, there's quite a lot of things you mentioned there. So,
Sorry.
yeah, so on-site solar and wind, I think is a big opportunity. It's again, financially, it's a big opportunity, as in physically connecting a wind turbine or wind farm to your data center, or hopefully, again, as I said, more of a microgrid where it's connected to a sort of an estate of operations, is a big opportunity. And we haven't really touched the sides of that yet. I think I can't remember the stats exactly, but the logistics sector did some analysis on the amount of capacity for solar, and they're only using about 5% of their roofs for solar at the moment. And so you can imagine and that's probably true across other sectors. So there's massive opportunity for that. I think it's a good story for data center operators as well, isn't it? It's good, saying a lot of data center operators will say we use 100% green electricity. I mean, the two issues with that are, one, that's only on a net basis. So you're saying I use 100 gigawatt hours, so I bought 100 gigawatt hours. But of course, when you're using power at 6 p.m. on a cold December night, it's on you're not using renewable power. It's you're using gas like the rest of us are. So it's slightly it's not correct in the system level, but also just from a human level, it doesn't really inspire you, does it? If I use green electricity, you can't see anything. Whereas if you can say, here's my data center and here's my solar farm, and they're physically connected, it just has an immediate human appeal. So there's a big opportunity there. I think on solar and wind, from a big system level, from a proper UK or even global energy system, as I was saying earlier, the future you need to think about is we are going pretty much 100% solar, wind, nuclear, and then probably some bits and bobs, maybe some hydro. It obviously depends globally. There'll be some variation, but that and that makes the generation very inflexible, and it means the demanders of energy need to be more flexible, or there's an opportunity to be that. And I think that's the big opportunity for data centers, is to think of themselves as an active participant in the energy system, rather than just seeing themselves as a sort of a user that needs to minimize demand. It's much more two-way. It's much more interactive. So, and that solar wind point on your SMRs, small modular reactors. I mean, I don't know. Who knows where small modular reactors will end up? It would be a nice, again, could be a nice co-location in the more general industry sense of putting things next to each other. If your SMR is on a site where I've got a data center, I mean, SMRs will like to run. So when you build a nuclear generator, you want it to run for long hours, partly because you need to recoup your energy costs, but partly because they're better running than turning on and off, turning on and off. And so there's a good opportunity there to put an SMR on the same site as a data center and use that power demand, because it helps them both. If you like, you've got a clean energy supply, and the SMR has got a consistent energy taker with a good power demand. And the question for SMRs, I think, probably is price. I don't know what their prices are at the moment. I don't know if anyone, we're still in a price discovery mode for SMRs, but the price will be a big question. And I suppose the other one will be security issues. They're going to need to be on sites where you've got good security, I would assume. On the green hydrogen point, yeah, I think so. Green hydrogen has a role in our energy system for sure, and it has a role in lots of processes. My expectation is it probably has a role in peak energy generation. So back to my point earlier, when you've got a system that is solar, wind, and nuclear dominated, when there is a big spike in energy demand, you need something that can do that can generate that energy quickly and responsively, and that probably is a good option for that would be a green hydrogen power station, either a peaker or even a combined cycle system that generates a lot of power. I don't see what the role directly would be with data centers, as in data centers are electric, and therefore, unless you had a site where you had green hydrogen on the site running through a power generator to a data center, I can't see it working, and I don't think that's likely to be a very economic or good opportunity. I think that was the things you mentioned.
No, that's fair enough. And the industry's already talking about and to a certain extent doing it, although I think more in mainland Europe than in the UK specifically. The idea that the heat generated by a data center can then be repurposed. And I guess to
Yeah.
your sort of definition of co-location, shall we say, if there is the right infrastructure next door to the data center, then it's fairly easy to repurpose. If you have to take the heat too far away, then it becomes uneconomic, not very practical. So again, just your thoughts, I suppose, as to how much more of an opportunity is there than is currently being exploited when it comes to repurposing the waste heat.
Yeah, so it's definitely an opportunity because of course they expel a lot of heat. I think it's probably a small opportunity. One of the things about waste heat is anyone who looks at energy systems looks at waste heat and thinks it's just a massive galactic opportunity. We need to be using this stuff, but it's difficult. It's difficult to do that. It's difficult to capture waste heat. It's difficult to transport it efficiently. And so the opportunity is, as you say, I think it's to be more ensuring that the heat demand is right adjacent to the data center. So that might be, an obvious one would be a leisure center or a luxury hotel that uses a lot of hot water, something like that, where you've got a consistent demand. But it really does need to be baked in from the start because they really need to be close to it. This idea you can't really pump heat a mile or miles because it just gets phenomenally expensive. The other issue I think I suppose is it needs to be engineered in with the data center because how the cooling systems they use are evolving and change, and so that needs to be baked in. So I think there's some good opportunities very locally, but it's probably not part of a big wide heat network because the losses just get very big.
And in terms of what we've discussed and how best to progress it, I mean, clearly there are commercial benefits for much of what we talked about. So the data center industry, you'd like to think, would say, yes, we'll do this because it makes, well, not just sustainability sense, but also commercial. But do you think whether it's local authorities or clearly the government has decided that data centers are critical national infrastructure and seem to be taking more of an interest, do you think they have a role to play in saying, do you know what, data center industry at the moment is, to your point, you're or more generally, with this co-location idea, everyone's massively underusing the potential of solar or whatever it is. Therefore, this is the strategy. And I guess in the very early days, there was some very generous allowances, weren't there, to put solar panels on your roofs and stuff like that, and then they disappeared, etc. So just, I suppose, your thoughts as to how much the data center industry can do it for itself and how much you think the government at whatever level has a responsibility role to get people thinking along these lines more.
Yeah, so I think in terms of the generation issue, the solar, wind, that kind of thing, I think we've passed the point of needing subsidies and so on. I think there is, there is, I would say, a responsibility on the data center industry to embrace them, as I said, directly or indirectly, and a commercial logic to doing so. So I don't think the government needs to be too involved there, apart from enabling it by making it easy in the planning system and so on. The big thing I think is the grid. So the biggest challenge we now have for decarbonize our energy system is probably the grid. We can keep generating more and more energy. The problem is the grid can't cope at the moment for a host of reasons, historical reasons and just the way energy being distributed and so on. And I think there is a market failure there at the moment in that I was saying to you earlier, there's this sort of idea that every new development just wants to put its arms around the absolute peak amount of power it can possibly need, and it is causing huge backups in our grid, which is holding up housing development, holding up data center developments, holding up all sorts of developments which we need for growth. And although I and others have made the case for this more sophisticated approach, it isn't happening as fast as it should. And I do think there's a role for government there, whether that's funding a pilot project or incentivizing something, so that we can say, data center, come and see this site that is operating with EV charging and logistics and a hotel and a data center, and they're all in one electrical system, and they haven't all got their absolute peak wrapped around, directly connected. But it's saving the money, and it's meant they've had a smaller grid connection, which means we can put the housing down there. So I think we do need to get over that hump of proving this more to the industry, not just the data center industry, but more generally so.
And maybe in the sort of the final piece of the puzzle, well, not a piece of the puzzle, just the final question, I suppose, from myself. We're talking as if the sort of demands of the digital world and the AA that's going to be coming on stream and the sustainable world can potentially coexist. I mean, are we kidding ourselves that that's real, or, you know, at some stage do we have to say, you know, limit digital activity if we are going to get to net zero? Or do we say, well, it'd be nice to get to net zero, but if we're going to expand our digital world, AI and all the rest, then we possibly won't quite get there. But at least if we get 80% of the way there, then, you know, we can pat ourselves on the back. Just your thoughts, I suppose, as to digital versus sustainable.
Yeah. So I don't think there's any challenge. I think I probably am an outlier in the industry, and I'm quite optimistic about our energy system future. I think the net zero future is actually going to be a bit like our data, future. I often make the point that the interesting thing about renewable energy is it is a bit like processing power. It just gets cheaper and more powerful every generation, and that's unlike we had with coal and oil and gas, where they just sort of bobbed along on a commodity basis. And I don't think we've got our heads around that. So I don't think there's any fundamental contradiction. We can have net zero and we can have an AI revolution, and in fact, of course, they can co-seed each other, because AI will be crucial in optimizing that net zero energy system. I think it's incumbent upon the industry to make sure that we don't perceive that clash. And as I say, so that is being more innovative and flexible about how they use energy. And so I suppose that's the challenge, because otherwise they will face political challenges, and they will even face sort of, the newspaper challenge of it, just public opinion about that data centers why we can't have housing, that perception, probably wrongly, but that perception is something that we really need to avoid.
So, I mean, without getting too much into the politics of it all, when people are objecting to, the whole move towards net zero sustainability because it's going to cost all this money, or as you say, is that underneath that, if you look hard enough, it's whether it's the fossil fuel industry still kind of clinging on for dear life. It's just completely wrong for people to suggest that getting to net zero is going to cost so much money that it's going to make the country uncompetitive, etc. It's just that's a bit of a red herring for various sort of reasons that people are trying to protect something they don't want to lose. Is that right?
No, so that's quite a big question. It's quite a big question. So I think the point is, what I'm talking about is the energy future in, let's say, 10, 15, 20 years is wonderful, because you get to the point where energy only gets cheaper and it's infinite, and it's amazing. You still need to balance it because it's inflexible, that point I was making earlier. That's wonderful. There is a huge investment piece now. So, offshore wind power is not cheap now. Our transmission system does need distribution system does need upgrading. So that is investment now. So in a sense, you can both be right, as in there is a cost. It is costing us money now, but it unlocks a wonderful future that is, incredible. A bit like I think the AI revolution and the energy revolution are quite similar. They really are qualitative changes in how we perceive energy and processing power. But I think there is important that we make that transition as smooth as possible, because that is the point. There is a cost now, so we need to make that as smooth as possible.
Okay, I mean, I've taken a lot of your time, and I suspect conversations gone in directions that weren't originally anticipated.
That's right.
But
it's an interesting subject.
No, it is fascinating, and thank you for sharing some great insights. I really appreciate your time. Thank you.
No, thanks very much. Cheers, Philip.